The James Webb Telescope has basically found the clearest image of Proxima B on record, uncovering lovely bits of understanding into a probable tenable exoplanet. It obliges us, as we set out on an excursion via space, to uncover the insider facts of Proxima B and find out whether it could be the subsequent Earth. We have to take off into the significant expanse of space, wherein a mysterious planet exists inside the livable zone of its star Proxima Centauri. This planet isn't simply any regular rock, it is reality. See, Proxima B is located a trifling 4.2 light-years from us. This planet is included in mysteries and wonders. Could it be another Earth, with seas and life blossoming on its surface? Anyway, wait, there is more. Proxima Centauri B is not alone in that system around the Crimson Dwarf star. It has a companion, Proxima Centauri C. And who knows what other mysteries the star system holds. Perhaps there is another companion that we have not yet discovered. The secret doesn't stop there. Proxima Centauri produces about the same amount of energy from its star as Earth does from the Sun. Should this suggest that there may be water on its surface and perhaps even life? As we discover beyond our own solar system, we stumble upon a completely new universe of exoplanets, planets that orbit stars other than the Sun. With 200 billion stars in the universe, the possibilities for exoplanets are countless. Some exoplanets even wander freely, untethered to any star, like wandering tourists in space. Among them all, Proxima Centauri B stands out as a particularly striking and fascinating planet, with a year that lasts only 112 Earth days and a distance from its star that is generally closer than Earth is to the Sun. Indeed, one side of the planet is constantly washed in daylight, while the other side remains in eternal darkness. Now let's see Proxima Centauri, the star that Proxima B orbits. Proxima Centauri is part of the Alpha Centauri triple star system. This system consists of Rigil Kentaurus, also referred to as Alpha Centauri A, and Alpha Centauri B. Together, these stars form the closest star system to our Sun. The two stars, Rigil Kentaurus and Alpha Centauri B, form a binary system called Alpha Centauri A and B. These G-type and K-type stars appear as one star within the constellation Centaurus and are the third brightest stars in our night sky, with a peak luminosity just below 2.7. Proxima Centauri, also known as Alpha Centauri C, is a red dwarf or M-type star, located 0.21 light-years from the other stars, typically about 4 times the distance between Earth and the Sun. It is the closest known star to us. Proxima, in fact, means the nearest in Latin, and it was discovered in 1915 by Scottish astronomer Robert Thorburn Ayton Innes. Despite being our closest celestial neighbor, it isn't visible to the naked eye, having an apparent magnitude of 11.13, much fainter than the human eye's limit of 6.5. But don't let that fool you. Proxima Centauri is still a star worth studying. Red dwarfs like Proxima Centauri are among the most efficient in terms of power production. They may not produce much energy, but the internal convection processes at their cores keep them shining for trillions of years. Generally speaking, Proxima Centauri will remain a main sequence star for another 4 trillion years. However, the habitability of a red dwarf star like Proxima Centauri continues to be debated. For one, it is a flare star, meaning it has frequent and intense explosions. As a low-mass star, its habitable zone is much closer than the Sun's, projected to be somewhere in the range of 0.023 to 0.054 Australian dollars. But it's not as habitable as it seems. Proxima B is bombarded by extreme ultraviolet radiation from its star, much stronger than the radiation we receive from our Sun. It's so intense that even the lightest particles of hydrogen are stripped away, along with nitrogen and oxygen. However, that's not all. Just because a planet is at the right distance from its star doesn't mean it can support life. Proxima B might not have a stable atmosphere, which is essential for regulating temperature and maintaining a water-friendly surface. Without it, living creatures would be vulnerable to harsh space weather, making life almost impossible. So, while Proxima B might appear Earth-like on the surface, it is far from being capable of supporting life. Scientists remain cautious, as there are many factors that render it inhospitable. The venture to uncover the truth about Proxima B continues, and some still hold hope. One tool that has garnered the attention of astronomers is the James Webb Telescope. After years of anticipation, the telescope was finally launched in 2018 and could help us determine if there may be life on Proxima B. However, as with everything in science, matters are never as simple as they seem. Several modifications were needed to ensure the James Webb Telescope could provide accurate images. As Abby Tabor, a theoretical physicist at Harvard, explains, if a planet like Proxima B can absorb light from its star, it may also emit it as infrared light. The James Webb Telescope was particularly designed to detect infrared light. It could capture images of this light from the planet's surface and look for patterns that might confirm the presence of water or an atmosphere. But what if the planet has an atmosphere that is not conducive to life? The presence of an atmosphere does not guarantee the presence of life, cautions Ed Turner, an astrophysicist at Princeton University. Proxima B could be like Venus, with a thick atmosphere that is significantly denser than Earth's and extremely high temperatures that make life impossible. The journey to unravel the mysteries of Proxima B is not without its challenges. While the James Webb Telescope holds promise, there are other factors to consider. With costs mounting, space scientists are feeling the pressure to find ways to study planets like Proxima B. Much is at stake, but the rewards are even greater. The possibility to explore the unknown, to uncover the secrets of a distant planet that holds the potential for life, is a pursuit worth chasing. If the exoplanet were habitable, might we someday visit it? After all, it's the nearest exoplanet to us, which makes it so fascinating, practically like exploring our own outdoors. Even more thrilling is that it is more or less the identical length as Earth, and its role inside the habitable zone shows it is able to certainly have situations suitable for life. Proxima B's proximity additionally makes it an excellent target for our quest for existence beyond Earth. With it being so near, it's a high candidate for interstellar missions. Reflect on exploring this Earth-like exoplanet. Even though we cannot yet move there, it's in reality on the radar for future missions as technology advances. It's one of the most interesting endeavors in the area of space exploration. But it is no easy project. It'd take 75,000 years for spacecraft like Voyager 2 to reach the Proxima Centauri system. Nevertheless, an answer has been proposed. Solar sails. These extremely thin sails could be used to propel a spacecraft to the Alpha Centauri system, and Proxima along with it. This generation makes use of solar pressure to keep the spacecraft on path, doing away with the hassle of running out of fuel. And here's something even cooler. This cutting-edge technology could offer insights into the possibility of life on other planets like Proxima B. But like anything ambitious, there are barriers. For instance, the presence of an atmosphere does not always guarantee the presence of life. Proxima B could be like Venus, with a thick, hot atmosphere that is inhospitable. Moreover, get this, the James Webb Telescope can detect such emissions if it reaches a brightness of just 5% of the daylight side. Now, 5% may not seem like a whole lot, but when dealing with a star that's already dimmer than our own sun, it's quite significant. If Proxima B has advanced civilizations, they might use bright orbital mirrors to reflect sunlight from the daylight side to the night side. How cool is that? There are countless exoplanets waiting to be discovered in our universe. These planets come in all shapes and sizes, some being massive gas giants, while others resemble our own Earth. But what do we know about them? One type of exoplanet that has caught the eye of space scientists is the gas giant. These planets are similar in composition to Jupiter and Saturn, but are much larger. Some of these behemoths have been named super-Jupiters, surpassing even the largest planet in our solar system. But that's not all. There are also hot Jupiters, gas giants that orbit extraordinarily close to their host star, existing in a sizzling environment with temperatures that could melt metal. Imagine seeing one of those planets up close, with its fierce storms and extreme heat. Further to gas giants, there are also Neptunian exoplanets, which are similar in size to Uranus and Neptune. Among these are the hot Neptunes and small Neptunes, which are smaller and closer to their host stars than their gas giant cousins. These planets are often shrouded in mystery, with their atmospheres being hard to study from a distance. And let's not forget the Earth-like exoplanets, which resemble our own Earth. These planets come in various sizes, ranging from smaller than our planet to twice its size. There are even super-Earths that have masses more than twice that of our planet, but are still lighter than Neptune. One of the most fascinating exoplanets recently discovered is Proxima Centauri b, which orbits the star of the same name. This planet is classified as a super-Earth, with an estimated mass of about 7 Earth masses. Even though it is a relatively small exoplanet, it has sparked widespread interest among astronomers and scientists because of its potential for habitability, thanks to its position within the habitable zone of its star. Opportunity that it is able to support liquid water on its floor, making it a prime candidate for life forms. Could Proxima Centauri be the answer to the question of whether or not we are alone in the universe? Only time will tell. As the quest for life beyond Earth continues, Proxima Centauri b remains one of the most promising targets in the search for habitable exoplanets. Its proximity, size, and position within the habitable zone of its star make it an intriguing subject of study for astronomers. Yet, as we dive deeper into understanding this distant world, several crucial questions must be answered. Does it have the conditions necessary for life, such as liquid water on its surface? Does it possess a solid atmosphere that would protect potential life forms from harmful radiation? Or is it a barren rock, constantly bombarded by severe flares from its star, rendering it inhospitable? While the James Webb Space Telescope offers a new avenue to observe Proxima b in greater detail, it is not the only tool available to scientists. Ground-based observatories and next-generation telescopes, including the Extremely Large Telescope (ELT) under construction in Chile, are also being developed to study distant exoplanets in greater depth. These giant telescopes will allow astronomers to examine the atmospheres of exoplanets, such as Proxima b, and search for signs of habitability or even life. The ELT, once completed, will have the capability to directly image planets orbiting other stars and detect the faint signatures of gases that might indicate biological processes. However, despite the great technology at our disposal, the challenges are immense. Proxima b, like many exoplanets, is located extremely far from Earth. Even with advanced telescopes, capturing definitive signs of life will require patience and perseverance. Detecting a planet's atmosphere is already an enormous task. Scientists must be able to distinguish between the light emitted by the planet itself and the light from its star, which can easily overshadow the faint glow of the planet. Furthermore, even if the presence of life is detected, it is still far from confirming its existence. Scientists must search for unique biomarkers, chemical signatures that would suggest the presence of living organisms, such as oxygen, methane, or other gases that might be produced by biological processes. The concept of exploring other planets, especially one as close as Proxima b, also sparks the imagination. While sending humans to such distant places may still be far off, robotic probes and space missions are gradually moving closer to the possibility of interstellar exploration. Technologies like the Breakthrough Starshot initiative, which plans to send tiny light-powered spacecraft to Proxima Centauri at 20% the speed of light, are pushing the envelope on what is possible. These probes could carry advanced instruments capable of gathering data on Proxima b and its environment in real time, allowing us to investigate its habitability more effectively than ever before. However, even as we look forward to the potential for exploration, we must not forget the ethical considerations that come with seeking life beyond our solar system. If Proxima b is indeed home to microbial life, or even more complex organisms, the discovery could have profound implications for our understanding of life's origins and its spread across the universe. How would such a discovery reshape our view of life on Earth? Would we treat it as a treasure to be protected, or might we risk contaminating another world, as some have feared might happen with the exploration of Mars? These are questions that will require careful thought as we move forward. And then there is the bigger question: is Proxima b the exception, or is it just one of many Earth-like planets out there? As technology continues to improve, astronomers are discovering thousands of exoplanets in a wide variety of sizes, temperatures, and conditions. Some, like Proxima b, reside in their star's habitable zones, but most are very different from Earth. Some planets are gas giants that bear little resemblance to our world, while others might be rocky but too far from their stars to sustain life. Yet, as we build up a larger sample size, we may begin to see patterns emerge. Indicators of where life is more likely to exist and possibly where, one day we might send a probe to look for signs of life beyond our solar system.